Welcome everyone to this video. I'll be showing you how to use the first principle of derivative to prove the tan x dx is equals to sec²x. So from the first principle, which states that f prime of x is equals to f x plus dx minus f of x divided by dx. Now, here our f of x is equals to tan x, and of course tan x can be sin x divided by cos x, and of course our cos dx tends to 1, and sin dx tends to dx. So we're going to be using the first principle of derivative. So I'm going to have x prime of x, as f of x prime, or f prime of x rather, f prime of x is equals to sin x plus data x, is equals to tan x plus data x minus tan x divided by dx. So I'm going to have f prime of x is equals to sin x plus data x divided by cos x plus data x minus sin x divided by cos x divided by dx. So I'm going to find the LCM of cos x plus data x enclosed in brackets and cos x, and of course we can just join both together. So we'll have f prime of x is equals to you have cos x plus data x closed in brackets, and then so when we divide cos x plus data x enclosed in brackets by when we divide cos x plus data x enclosed in brackets by cos x plus data x enclosed in brackets, of course we left with cos x, so we'll multiply cos x by the numerator, so we'll have cos x sin x plus data x enclosed in brackets, extend this, minus this divided by this, cos x plus data x divided by cos x, you will be left with cos x plus data x enclosed in brackets. Now multiplied by sin x, you have sin x cos x plus data x, now divided by data x, which is here. So from here we'll have f of x prime, or f prime of x, is equals to, now again from the half angles you have sin x plus data x enclosed in brackets as sine x cos data x plus cos x sine data x. You put it in brackets minus sine x. Here again we are going to use half angles. That's the principle. So we'll have in brackets again cos x cos data x minus sine x sine data x. So divided by cos x in brackets again cos x cos data x minus sine x sine data x. So you can solve for that to get our f prime of x is equals to, we are going to expand the bracket, so we'll have cos x sine x cos data x plus cos square x, cos x times cos x give us cos square x sine dx minus sine, now minus sine x cos x dx can be written as, can have it as cos x sine x cos data x. So and then minus sine x multiplied by minus sine x sine data x, and in dx you have plus sine square x, sorry, I'm supposed to have divided by data x. Here we're going to have divided by data x. So we're going to have, okay, sine square x sine data x divided by cos square x cos dx minus cos x sine x dx. We're going to have dx here. So from here minus cos x sine x cos dx, we cancel cos x sine x cos dx, so we'll have our f prime of x, we will left it cos square x sine dx plus sine square x sine dx divided by cos square x cos dx minus cos x sine x dx. So sine x dx is common, wait, this is divided by dx, so the numerator sine dx is common, so we are just going to factorize it out. So I have f prime of x is equals to sine dx into cos square x plus sine square x divided by cos square x cos dx minus cos x sine x dx. Now we're going to have times inverse of dx, that's 1 divided by dx. So from here we'll have the f prime of x is equals to, now remember I said let's sine dx be limited to dx, so we are going to, so sine dx will become dx into cos square x plus sine square x divided by cos square x cos dx minus cos x sine, this is meant to be sine dx, so we are going to have sine dx here sine dx times 1 divided by dx. So dx here will cancel this, you'll be left with f prime of x is equals to cos square x plus sine square x divided by cos square x cos dx minus cos x sine dx. Sine dx. Now we are still going to limit dx cos dx and sine dx. We are going to limit it, so we'll have f prime of x is equals to cos square x plus sine square x divided by cos square x. Of course, we said cos dx should be limited, tends towards 1, and sine dx tends towards dx. So here we'll have cos square x multiplied by 1 minus cos x dx. So here we'll have the f prime of x is equals to cos square x plus sine square x divided by cos square x times 1 give us cos square x minus cos x dx. And of course, from our trigonometry, cos square x plus sine square x is commutative, so cos square x plus sine square x will give us 1. So we'll have 1. So we'll have f prime of x is equals to 1 divided by cos square x minus cos dx. Now we are going to limit dx to 0. So wherever you see dx, you replace it with 0. So we'll have our f prime of x equals to 1 divided by cos square x minus 0 and minus cos x multiplied by 0. So this will give us f prime of x is equals to 1 divided by cos square x, and of course 1 divided by cos square x will have sec square x. So we've been able to prove that the tan x dx is equals to sec²x. So thank you for watching this video. You're welcome. Next time.